Hello everybody, so welcome to section 2 of this videos on calorimetry. So in the section 1 we talked about the definition of 1 calorie. So 1 calorie is the amount of heat required to increase the temperature by 1 degree Celsius for 1 gram of water. This is an approximation. Actually, it's it's increasing the temperature from 14.5 to 15.5 degrees Celsius, right? So can we understand what is the amount of heat energy required in general to increase the temperature of the body? So let's say the heat energy that I need to give is delta Q. This is observed that it's always directly proportional to the mass of the body. What this implies is that if I have 2 grams of water, then I will have to give 2 calories. If I have n gram of water, I have to give n calories for 1 degree Celsius rise, right? Now delta Q is directly proportional to delta T as well, which means that if I want to increase the temperature of 1 gram of water by 1 degree Celsius, then I need to give 1 calorie. By 2 degrees Celsius, then I need to give 2 calories, etc. So in general, if I can generalize this, delta Q is directly proportional to m into delta T, and or delta Q is equal to C m delta T, and the C is called the specific heat capacity. Different bodies have different specific heat capacity. So if you were to take Mercury requires only 139 joules for increase in temperature by 1 Kelvin. So that's very less heat, very less energy is required to increase the temperature. Probably one good reason why mercury, other than being liquid, is used in thermometers. For iron, it's approximately 483 joules per kilogram per Kelvin. For glass, it is 504 joules per kilogram per Kelvin. For aluminium, it is about 882, and for water, it's about 4,800 joules per kg per Kelvin. So water is absolutely a bad conductor of heat. It requires a lot of heat energy to increase the temperature by just 1 Kelvin. That's what this says. So definition of specific heat capacity is amount of heat energy required to increase temperature of a unit mass of a body by 1 degree Celsius or 1 degrees Kelvin. Now it is denoted by small c, and the unit SI unit can be easily derived, right? So C is equal to, we know, delta Q by m delta T. So joules per kg per Kelvin or per degree Celsius. It's all the same. And so that's about specific heat capacity. So now let's talk about just heat capacity. So let's assume that you have a vessel, and this is made of iron, and you go to a shop and you want to buy this vessel, and a shopkeeper tells you that 1 kg vessel, that's approximately 500 rupees, and he has another 5 kg vessel, and that's approximately 1,500 rupees, right? And your mom has asked you to buy this vessel to cook, to do heavy duty cooking, right? Maybe meat, or maybe maybe something, tapioca or whatever, which requires a lot of heat. So which vessel will you buy? Which vessel will you buy, 1 kg or 5 kg? It's very easy. So we observe that iron has approximately specific heat capacity of iron, as the value of specific heat capacity was 500 joules per kg per Kelvin or per degree Celsius. So for 1 degree Celsius rise in the vessel 1, which is 1 kg, the vessel can absorb 500 joules. The vessel with 5 kg, for 1 degree Celsius rise, it can absorb 2,500 joules. It's actually per degree Celsius, per degree Celsius. So so this means that the 5 kg vessel can absorb more energy and still not increase the temperature, which makes it a better cooking vessel. So vessel with vessel of 5 kg is much better because it can absorb more energy and still contribute to very for every 1 degree rise in temperature. Now this is exactly what you mean by heat capacity or thermal capacity. So heat capacity or thermal capacity of a body is amount of heat required to raise temperature by 1 degree Celsius. In other words, we are completely discarding the mass here, right? What I mean by that is, so in the vessel 1 we found that it required 500 joules per degree Celsius, and vessel 2 is equal to 2,500 joules per degree Celsius. So we're completely discarding the mass here. We don't care about the mass. So this is a good way to characterize which one is a better vessel for cooking. Let's go back to the formula. So delta Q we know is directly proportional to delta T, and in this particular case we don't want to consider mass, right? So we don't care about the mass. So this is equal to heat capacity, specific heat capacity into delta T. So this is called heat capacity. heat capacity of body. Now we know that delta Q is equal to mc delta T, right? This is specific heat capacity. So in other words, C dash is equal to m into C, right? So specific heat capacity, it depends on mass of body. That's the other key deduction that you need to remember, apart from its unit, which is joules per Kelvin. All right, that's the end of this section of video. The next section of video we will find out how to determine the specific heat capacity of a material or body. See you then. Bye.